In this video, we derive the formula to find the vertex of a parabola in the form y equals ax squared plus bx plus c using the method of completing the square. And then we do the same thing for the problem y equals x squared minus 4x plus 5. In this video, I'm going to show you how we derive the formula for finding the vertex of a parabola when the equation is in this form. Now remember, f of x could be thought of as y. So this is the same thing as y equals ax squared plus bx plus c. Now the goal is to get it into a form like this, y equals a, it's the same a, x minus h squared plus k, because we know if it's in that form that the vertex would be hk. Well, the key to doing this is to take this form here, y equals ax squared plus bx plus c, and complete the square. So that's what we're going to do. All right, step one is we're going to subtract c from both sides. So that gives me y minus c equals ax squared plus bx plus c. And now the trick is I need to complete the square, right? So remember, when we complete the square, we just want x squared. We don't want this coefficient of a. But instead of dividing everything by a, keeping in mind we want the final answer to just be in the form y equals something, instead I'm going to factor out an a. All right, so if you factor out an a, you have to think, what do I have to multiply back inside the parentheses by? Now, basically, a way of getting this is to divide each thing by a to see what's left. So ax squared divided by a is why you would have still this x squared here. And bx divided by a would give you b over ax. Now, verify that that indeed, if you did the distributive property, does give you back to ax squared plus bx. See? A times x squared, a times b over ax. And what I'm going to do here is I'm going to leave a blank inside the parentheses here because it's not quite completing the square yet, right? All right, so I'm going to move this over a little. Y minus c equals a times, and inside the parentheses I've got x squared plus b over a x. All right, now here's the tricky part. What would I have to add inside this parentheses to complete the square? Well, I like to go down and write down what would be in here if I did complete the square correctly. You would have to take half the coefficient of x, right? So what's half of b over a? Well, that would be b over 2a, right? 1/2 times b over a is b over 2a squared. Well, then what would be added inside of here would be the b over 2a squared. So I'd have b squared over 2a squared, which is 4a squared. Now here's the little tricky part right here. If you're adding that inside the parentheses, okay, right? I just added something that really wasn't up here. Then note that I've really added to this side of the equation a times this b squared over 4a squared. Okay? Well, I have to make up for that by subtracting a b squared over 4a squared, right? So if I add this, because it really wasn't there in the previous problem, the previous step, I need to subtract the same thing, a b squared over 4a squared. Okay? So that's, notice, if you cancel the a's, that's just b squared over 4a, right? And now I'm just going to add c back to the right side of the equation. Then I've got it in the form a x plus b over a, I'm sorry, b over 2a squared. I'm going to add c to the other side, and just so you can see this with being added, it's really a c, right? There's the c minus b squared over 4a. You do not need to put this in parentheses, but there's a reason I'm doing it. In fact, I'm going to change this to blue as well. Almost done. So basically, if I've got plus b over 2a, then if I read this as the vertex point, it would have to be negative b over 2a, right? For the x-coordinate. And then the y-coordinate is c minus b squared over 4a. That's actually the formula for the vertex point. Now, most people don't memorize this formula. What they remember is the x-coordinate is negative b over 2a. Also, remember that tells you that the axis symmetry, the equation, is just x equals negative b over 2a. In fact, some people just write that down first, because if you set what's in parentheses here, x plus b over 2a equal to 0, you get x equals negative b over 2a. Once you know the x-coordinate, you could go back and just plug it back into the formula, and you've got it. So remember what we did is we just took this, we're just now have it in the right formula, y equals a x minus h squared plus k. That's where I got the vertex point from. Remember? hk. So that's why when you have something in ax squared plus bx plus c form, right, y equals ax squared plus bx plus c, to find the vertex you could simply plug in negative b over 2a for x and solve. Now, you don't have to memorize the formula. You could do this on any problem, complete the square yourself and get it. So let's just do one quick problem doing that. So let's say where you were asked to graph this, you're asked to find the vertex point, you're asked to find the axis symmetry, etc. So what we could do is, if we want, we could just get it in the form where it's easy to pick out the vertex. So first I'm going to write that as y, and I'm going to go ahead and just subtract 5 from both sides, so it's easier to complete the square. So the question is, what am I adding to both sides? Well, I come down here. This would have to be an x minus 2 squared. And by the way, if you're not sure how to complete the square, look at my videos on completing the square and the quadratic formula. So I'm going to have to add 4 to this side, right? And since I'm adding 4 to this side, I'm going to also have to subtract 4. Okay. Now, instead, you could add 4 to both sides. If it's easier, you could just add 4 here, add 4 to the left. Either way works. So there's my minus 4 here. Okay. And then all I have left to do is add 5 to both sides. So I have x minus 2 squared. And if I add 5 to both sides, I'm going to have plus 1. So notice the axis of symmetry. I'm just going to write axis. It's going to be x equals 2. And the vertex point will be 2, 1. Okay. Now we're just going to verify we get the same thing by plugging in using the formula. So we take the original problem again. I'm going to write it as y equals ax squared. I'm sorry, not a. Y equals x squared minus 4x plus 5. And instead, if we use the coefficients, a equals 1, b equals negative 4, c equals 5, I could use the formula x equals negative b over 2a. All right, b is negative 4, so I have the opposite of negative 4 over 2 times 1. So I basically get 4 over 2 or 2. So I get x equals 2, right? Which matches exactly what I got here. X equals 2. Look at, I got x equals 2. So what would I do if I wanted to find the vertex? Since I know that x equals 2 is the axis, right, of symmetry, then the vertex, you're going to put in 2 into the equation here. So I take this equation, right? And I'm going to plug in 2 for x. So y would be equal to 2 squared minus 4 times 2 plus 5, which is 4 minus 8 plus 5. And that's 1, isn't it? So notice I get the same vertex. And that's where that formula comes from, the x equals negative b over 2a. So you can complete the square if you'd like, or you could just use the formula to figure out the vertex point and the axis of symmetry.